for Centella Solution, and I also manage the events for ABD Society. For those who don't know, ABD is a nonprofit based in Charlotte, with mission to establish Charlotte as a national analytics and big data hub. Thanks to UNCC, we are hosting these events monthly, and our next event is March 19th. Hope to see you there. Moving on to our speaker for today, Philippe Loire, Director of Machine Learning at Computational Medicine Center at Thomas Jefferson University. His work throughout the years contributed towards the discovery of new molecules and better understanding of diseases and biological pathways. Data science and big data play a huge role in his work, where he has authored and co-authored dozens of papers in leading medicine journals. So I will hand it over to Philippe.
Thank you, Boyana, and I want to thank ABD Society and UNC Charlotte for the invitation to do a talk here. But I also want to thank everyone here coming out during your lunch break to hear about this. So thank you. Like Boyana mentioned, my name is Philippe Loire. I'm the Director of Machine Learning at a medical university. It's actually located in Philadelphia. Though I live here about just 30 minutes north of here in Davidson. What I'm going to be talking about today isn't related to the work that I do at my work, but just as a resident, just as a North Carolina resident. Having moved here about 4 years ago, I started seeing cancers and the concern for cancer clusters in the news about maybe 2 years ago. And I started asking the questions, well, can I help in any way? How do we kind of better understand this? And that's the inspiration for this presentation of detecting cancer hotspots while preserving patient privacy. I'm involved in two ways with the cancer data. One is there's a nonprofit up in the Lake Norman area called Launch LKN. And a few years ago, I started a machine learning group there. It's called the Machine Learning Group. And we're basically a bunch of data science, machine learning nerds and enthusiasts. And our main objective for the interest group is to help people get hands-on and learn the data sciences. So pretty much all the techniques that we're going to be talking about here, we're exploring as a group, you can find us on Meetup. There's going to be a URL at the end. We're exploring as a group, so we invite anyone here to join us, and if you're, even if you're new to the field. And the second way I'm involved is there's another nonprofit that it stemmed from the Lake Norman Chamber of Commerce, where folks were concerned about cancer clusters, and it's called the Healthcare Collaborative. So I'm on the analytics committee for that as well. So with that, just a quick agenda. We'll talk about the brief background on potential hotspots in this area, and just what does it mean for there to be a cancer hotspot. Challenges with the registry data. Talk a little bit about some of the registry data from the North Carolina's Health Department. Data privacy techniques. That's the bulk of the machine learning and kind of crypto data science aspects we'll be talking about. Will be in that section. It will be a very short plug on a hot emerging area in the computer science field called Causal Inference. And then lastly, if you have time, you want to get involved and you want to learn more about some of these techniques, how can you do that? Before I talk about this, I just want to ask you all a couple questions. Who here has heard about the cancer hotspots in the news in North Carolina? Okay, like half, like roughly about half. There's two takeaways I would love for y'all to get out of this. The first takeaway is, I'm going to make the assumption that the data that the State Department has on their registry, and I'll talk more about it, is correct. It's usable and it's good. But the takeaway is, I think we can do more. I think what you'll see is the data is there, and I think we can do a lot more with it. And then the other takeaway is, as we talk about some of these data privacy techniques, a lot of these techniques are applicable to other fields besides just healthcare. And as the explosion and emergence of big data affecting AI in just about every industry, think about how these data privacy techniques can unlock data in general for the other industries too. So the main areas, and the reason I heard about these is there was two cancer hotspots that I saw in our local newspaper delivered on our driveway. One of them is kind of south of Lake Norman, so like we're down here in Uptown. But one of them is a cancer cluster that I heard a lot about in the news near Hopewell High School in Huntersville. And initially they talked a lot about an eye cancer, an ocular melanoma called uveal melanoma. Another cancer hotspot that made the news a lot is kind of southern Iredale, kind of roughly near the Marshall Steam Station power plant. And that, at least initially, you heard more about thyroid cancers, and specific like papillary thyroid cancers up in that area. And these are kind of generalities because it doesn't mean that there is no uveal melanoma up here and thyroid down here, but those are kind of the two areas that I see in the news a lot kind of talked about. And very recently, I think this was only, February 11th, Aaron Brockovich started to be more interested in our area. And there's been videos made, a lot of news articles that says basically plea from the Lake Norman town to help kind of troubleshoot and figure out what might be going on, if anything, in this area. And so Erin Brockovich, she was made famous in the movie Erin Brockovich, was she played by Julia Roberts or so. Anyways, she's been helping give it media attention, but it's been getting it even before she was involved. So a little bit about just what the data looks like for thyroid cancer, for papillary thyroid cancer. This is a report from our health department in North Carolina, where they show that at least they basically broke Iredale up into pieces, and they showed for the two southern parts of Iredale, there's these two peaks are kind of probably the most interesting. Is there roughly 2 to 3 times, they have roughly 2 to 3 times the expected incidence rates for those locations when compared to the national rates of thyroid cancer. We'll talk a little bit more about this. And this report came out, I think, January roughly of last year, and then a few months before they did something similar, but at the zip code level. This is my request here. I'll talk a little bit about it, but this is like, okay, they told us a little bit about one cancer in one region, but what about everybody else? What if you didn't live in those regions? What if you lived in other towns? What if you're in Cornelius, Huntersville, Charlotte, South Charlotte? Are there any issues there? It took months to get this data, and I'll talk a little bit about that and why I think that can be improved. We won't go into kind of what this means, but essentially, with a little bit of work, they were able to give us numbers for what thyroid cancer looks like for northern Mecklenburg. In this case, that means Davidson, Cornelius, and Huntersville for thyroid. So why was this so difficult? I think the primary reason is smaller areas are not standard in the healthcare registry in North Carolina. So the reason, just to get this data here where it showed that these two southern regions had a higher incidence rates, it took a concerned citizen whose family member had thyroid cancer, and she began talking to other people in the area and said, hey, look, there might be a problem here. Let's ask for more information. And it took those type of repeated requests to get this data generated. This was not something that North Carolina just did without being asked. And I think that's caused some type of frustration in the public here, because if someone moves somewhere, they want to at least be armed with a little information about what might be going on in the area. They don't want to have to find out after, obviously, a family member gets sick. But in general, small areas are not standard in how the state does it. The state does things at the county level. So by does it, that means they report incident rates of particular cancers and make available to the public incident rates at the county level. Now, Mecklenburg County is over 1 million people, has over 1 million people now. And obviously they can do it. They have, the capabilities are there to do smaller regions. So asking the state to do it, it's not, I think what's important here, it's not a skills issue. They know how to do it, and they have done it. They've done it for Northern Mecklenburg, they've done it for Iredale. It's just not a standard. It's just not something they do standard. Like, here's a map from New York State. New York State passed a law that says they have to actually do it at the census block level. They have to do it at the smaller scale level. Another issue is only aggregated data is provided. So as if you're an analyst, especially in machine learning, you're only getting the number of people that are told they have a particular cancer for an aggregated group of area of data. So you can't actually use the data to do any model building. Another problem inherently with this is not only not being able to do analytics on it, but you can't validate the data. We can't even say, did they do the right analysis in Iredale? Did they do the right analysis in Northern Mecklenburg? Because we do not have access to the non-aggregated data. So 2 months to receive the information about North Mecklenburg. I'm going to say that this wasn't just asking them in order to get the data. I had to pull up GIS maps on my own and tell them exactly what years I was interested in, what census block groups we're interested in. It took a tremendous amount of back and forth that probably the normal person would not be able to do. There has to be a better way. This is information from, our tax money pays for this healthcare registry in North Carolina. What about other cancers? Other areas all across North Carolina, even Charlotte? Importantly, there's a lot of things it's not doing. The data that I showed from Northern Mecklenburg is not doing. It's not accounting at all for race, sex. For the most part, it's not accounting for population growth. The reason this is important to account for these is every cancer has a unique signature about who's impacted. If we take thyroid cancer, for example, thyroid cancer, if you're told you have thyroid cancer, there's a very good chance that you're white, that you're female, and that you come from a fairly wealthy community. None of that is accounted for in this data. And we can't do anything about it because all we have is aggregated data. Adjust for overdiagnosis. There's things in particular, like thyroid cancer, there's an epidemic of overdiagnosis. For example, it's estimated that I think over 50,000 people are going to be told in the United States that they have thyroid cancer. Of those, most of them are going to be white females. And the New York Journal of New England Journal of Medicine There's a recent publication that said 75% of those are a result of overdiagnosis, which essentially means that the patient may not have had to go through that. Not only is there surgery, there's lifelong treatment and drugs that are needed, there's financial burdens. But you can correct for this information if you have the right data. Not necessarily at the aggregated level, but there's demographics that are more likely to be affected by overdiagnoses. Even things like information about the malignancy, how big the malignancy is, all that can help correct for this important information. Another thing we'll touch on briefly is we get some type of rate, but we don't learn anything about conclusions or causality. So with that, we're going to say, how can things be better? Because there's some really, really cool machine learning and data science techniques that can improve this. And we're just going to make the assumption we have the data. And we're going to make, yes, it can be better. You can track people as they move. You can take that into account. Data can always be better. But let's pretend we have this data. With the data, when you can use these techniques and make things better. These are some four techniques we'll briefly touch on. De-identification, differential privacy, secure multi-party compute and federated machine learning. And the idea is patient privacy is critical. You can't compromise patient privacy. Can you unlock the power of the data while preserving patient privacy? And that's what this is about. Here's an ideathon that out of the launch Lake Norman we did last year. And we basically said, if you can control your own healthcare data, what would it look like? So as you learn about these techniques, don't only think about this cancer registry. Think about liberating data in general. If in this particular ideathon we said, well, if you can control your own healthcare data, right now most people probably don't feel they control their own healthcare data. Even if you go get a scan somewhere, if you ask for it and you eventually ask enough people, you can eventually get a DVD or a CD with your info. But most people really don't feel like they control their own data. And it's not just healthcare. And in some of these techniques, you can start allowing this. All right. Governor Bill Weld of Massachusetts. I think he recently, I haven't heard from him in a while, but I think he recently tried to run against Trump, I think this year, so he kind of came out of the woodworks. So he's a Republican. He was an ex-Republican governor of Massachusetts, and he did a lot to help with healthcare privacy reform. Kind of oddly, it wasn't what he said. It's not what he said that helped. It's actually what happened to him that helped. So he was doing a keynote at a graduation speech. I think it was in 1996. While he's doing a keynote, he collapsed. That was his one of his main contributions to healthcare privacy. He just collapsed, completely passed out. So he couldn't, he couldn't do the speech anymore. But he was a well-known figure. Very, I think it made the news a lot. And so there was a amount of research that was being, it was a group of data from the Insurance Commission, Massachusetts Group Insurance Commission, that was going to be shared to researchers. And he assured, he assured people that there was the right identifiers of the data were removed to protect patient protect the privacy of the patient. So they gave it to the researchers. And so there's a graduate student at MIT, Latanya. She paid like $15 or $20 to get her voter roll information from Cambridge, Massachusetts. And with the voter roll information, took the insurance data and actually identified Governor Weld. And so she basically used a different data set, an external data set that was given to the insurance company, and did what's called re-identification. Sometimes you hear the popular Netflix variant of this. This is the healthcare variant. So with the voter roll, they were able to find out that, I don't know the exact details, but I think it was roughly, there was six males that were admitted on that particular date, or 6 people that were admitted on that particular date. 3 of them were males, and only 1 of them had Governor Weld's zip code. So they used this information, and they actually went to the data that they had, and they were able to tell Governor Weld exactly what diagnosis he had, and even what prescriptions he was on. So he was completely shocked. At the time they thought if they just removed the patient name from the information, that everything would be safe. Anyways, with that, there were some major provisions put in HIPAA in 2003 to actually help a lot with data privacy, and that's de-identification is basically you're removing identifiable information from the data. For example, zip code level information you can't have. You have to, I think, keep the first. If you're going to put any zip code at all, you have to keep the first 3 digits only, and you can't use the rest. But there's a whole lot of other provisions in HIPAA to help with data privacy. Here's another one called Differential Privacy. If you have an iPhone, I think your iPhone uses this technique, quite a bit with your type ahead. Who here's heard about Cynthia Dork? Well, she's really big. She's a big name in this field. Here's her popular equation, and we'll talk about D1 and D2 just very briefly. And we don't have to go to specifics of the equation, but if I asked everyone in this room, we'll call you all the D1 data set, and I'll ask, please don't raise your hands. Who's had their tonsils removed? And everyone kind of just writes down on a little piece of paper and passes it in, and we might find out that 30% of this room, variable D1, has had their tonsils removed. But if Bojana goes to the bathroom, and now everything in this room, we'll call it D2. We'll call it D2 now. So she's removed from the data set. And I'm just going to ask the class the same exact question. Who's had their tonsils moved? You're answering the query, you write it down, you pass it in. We learn a little, now I have two answers. And the issue with that is, alone, none of the queries compromised patient privacy. But together, how that number changes, we've now compromised Bojana's privacy. Now, if she's had her tonsils removed, we'll see that 30% number drop. So the beauty of this algorithm is it makes sure, you can help make sure that there's no patient data, that any one patient affects the statistical properties of a data set. And if you can do this, if you can make sure that no one particular patient affects the statistics of a data set, then you're protecting that person's privacy. And in fact, another cool thing is actually there's an epsilon value. So you can actually, kind of proportional to that epsilon value is a privacy budget. So one thing you'll see in privacy quite a bit is there's the accuracy-privacy trade-off. So the more privacy you have, you kind of compromise your accuracy, maybe even expand your confidence intervals, your uncertainty. But if you want to improve your accuracy, you can hit and you can affect your privacy. You can reveal private information. You can actually control that, your privacy budget with epsilon here. So one technique, and it's a very common distribution called the Laplace distribution, is the way to solve it just in this tonsil, did I say tonsil? The tonsil example is you inject randomness into the mix. So when I get the answers from the room, there's a little bit of randomness assigned to it. So when Bojana leaves the room, both of them have a little randomness. So it might be 32%, it might be 29%. It's almost an inverted form of plausible deniability when you think about it. That's kind of how this kind of privacy works. Another important thing to note here is this is still aggregated data. Differential privacy still is applicable for aggregated data. But the last technique we'll discuss, you can do even more than aggregated data. How am I doing on time here? Oh, we're good. So Dr. Yao, we're good. So secure multi-party compute, I think sometimes it's referred to as private computation. Well, there's two Turing Award winners. I think he's one of them. Let's see. Yeah, Turing Award is like the Nobel Prize. It's the highest honor in computer science, and so it's the Nobel Prize of the computer science field. He's one of the winners, and he came up. It's a form. So normally in encryption, you have private data, and you encrypt it so that no one else can see your data. And that's traditionally what cryptographers have looked at. This is a little bit different. This is saying we don't want to encrypt all your data. We want to only make secret the data we don't want to make revealed. So it's something called secure multi-party computation. I'll give an example of this, but it's a way to exchange information on only the information that you want to exchange and nothing more. So he came out with what's called the millionaire's problem, and now I guess it's called we may have to call it the billionaire's problem. But what if you have two billionaires sitting next to each other and they don't trust anything, and they look at each other and they say, I want to know who makes more money. But the problem is they don't trust anyone. They have big egos, and they don't have a trusted third party that they rely on. In fact, they don't even want to type into a computer because someone could have hacked the computers. They don't want to type into the computer on how much money that they make, but they still want an answer. They still want to know who makes more money. But that's it. So they don't want to know if they make $1 more than the other person or $5 million more than the other person, because that's revealing too much information. They just want to know who makes more because their egos are hurt. So to give a brief example, and so if you think about it, this is a greater than, the computation is, greater than or equal, greater than or less than. You want to do a secure way to do a greater than or less than. I'll explain a way to do this slightly differently, and sometimes it's referred to as the socialist millionaire's problem. And just to simplify things, we're going to get rid of the greater than and less than, and we're just going to make an equality. Do we make the same amount of money? So I'll give an example that, let's see, I don't know what names have. So Bojana, I'm going to pick on her again. We both mow the lawn for one of our neighbors. And we know roughly we won't make any more than $20 an hour, and we won't make any less than $1 an hour. But our neighbor assures us that he's paying us the same amount of money. Bojana and I are a little skeptical. We're not sure we believe that person. But we do know we don't want to reveal any other information. For example, if she makes more money than me, neither of us want to know that. So one way to do this with secure multi-party compute, kind of the technique being used here, is you have 20 different boxes for $1 an hour, $2 an hour, all the way to $20 an hour. Each box has a little slit on it. Both Boyana and I have 20 pieces of paper, all that say one yes and 19 no's. And we both go to the boxes and we just put our yeses and no's, and we put a yes on how much money on the box with the amount of money that we make. So then once we put our 20 pieces of paper, we remove the labels of the boxes, and then we scramble up the boxes. We just mix them up. So we don't know what box is what. And we literally just flip them upside down. And sure enough, if we made the same amount of money, one pile would have 2 yeses. But if we had 2 piles that had the yes in this pile, this in this pile, we know we don't make the same amount of money, but we don't know anything else. Now, it's not so. It's actually trickier than this, because that particular example kind of assumed that we followed by the rules, that we didn't cheat. But there's ways we can protect against that too. But you extrapolate this technique out, and you can start exchanging information, and only the information that you want to exchange. I don't know if those guys know that. I think some of their money is already made public. And the last technique is that I'll talk about is what's called federated machine learning. I think there's a little bit of debate on who was the first to do this. I think Google was one of the first to kind of productize this, and I've never tried it myself, but there's a Google product called Gboard, which is like a virtual keyboard. I think you can get it on your Android devices or your iPhones and things like that, and they use this technique. But it's very interesting because it's a way to do machine learning without giving up your data. So imagine you're a healthcare company with a bunch of radiology images, and there's another hospital, different healthcare system, that also has a bunch of radiology images, and you want to make a model that can find tumors, let's say pancreatic tumor predictions. You want to be able to predict on that image, but you want to be able to train your model on data from these hospitals. So what federated machine learning can do is it separates the model from the data owners. To have a hospital system give up their data is really, really difficult. In this case, they don't give up their data. The model gets sent to the hospital. The hospital would use their data. You see this a lot in neural networks where, to step back a second, when you train a neural network and you're feeding it training data and the neural network's improving, you can think of it as these connections in the neural network being little levers that you're adjusting, little weights. At the end, they're weights and biases, basically just literally numbers that you're tweaking, you're dialing. And so as the model gets better, as it can better classify a cancer, the knobs turn. And the more data, the more training data you give it, normally, the better the model performs and the better it can identify that particular cancer. So what happens in this case is the data stays at the hospital, but the model goes to the data. The hospital system does the training on their own data. They do the tweaking, they do the little knob tweaking, and then they send back the model only to the model owner. So the data never leaves the hospital system. And then the model gets sent to the other hospital system, so on and so forth. The data can be improved. And the data is not left here. These are hospitals, example, edge computing. This is very popular in edge computing.
Can you take a question now?
Yeah, sure.
Do you think that would work if the different hospitals had different features? you know, like hospital A had a certain set of features that B didn't and B had, et cetera. You think you could do that type of model training and still have a decent output?
Great, it's, the vocabulary around the query becomes critical. So I think there is some standardization that will be needed once this kind of comes in practice. I think UPenn, if I remember correctly, UPenn and like 19 other hospital systems started a project. I think the Intel site has more information about it. They're one of the first to kind of try it out on medical imaging, but I have a feeling some type of standardization will be needed at first until there's a vocabulary. For images, for example, it's possible that the images are needed, that the input neurons, for example, typically on I'm just thinking out loud here, on what's called a convolutionary neural net, there's an input neuron for every pixel.
Mm-hmm.
Well, obviously, if you feed in an image with different pixel sizes from one hospital and the other, it's not gonna port well to that input neurons. But so that's a really hard problem, and it's a really important problem for federated learning to solve. What you just mentioned. You see this a lot with edge computing. So the mobile phone example. So instead of hospitals, imagine your own healthcare data stored right on your phone. Imagine you control your own or on your own cloud, something that you control, not the hospital, not the insurance companies, so on and so forth. You can imagine, but you still want to. Let's say you, as a patient, still want to provide value to maybe to researchers and whatnot. You can start sharing your information without giving your data to somebody else, but it's still useful for their models. Here's a quick plug. It's not around data privacy, but it's another group project out of the machine learning group at Launch LKN. It's called Causal Inference, but it is related. It's enough related to the healthcare discussion because it helps an important question in answering why. So pretty much everyone in data science has heard the term correlation is not causation. You learn it in statistics 101, and most people stop there. They say, okay, you cannot find why now because, hey, look, it's a correlation, but doesn't mean causation. Here's another Nobel Turing Award winner, Judea Pearl. If y'all have anything with Bayesian networks, Judea Pearl, I think is the father of Bayesian networks. Anyways, he got the Turing Award for fundamental contributions to artificial intelligence through the development of the calculus for probabilistic and causal reasoning. He's arguing that now is the time. Right now, he's been studying this for 20 years, but now there's an explosion going on in what's called causal inference. And that is, data can give you the probability of causation. And science has been basically stifled because people have stopped even trying to use data to find cause. So we have a study group on this. We're looking at his book. A guy in our group named is John Lingle is the leader of this, and he's a doctor in social psychology, but it's a very fascinating topic. It's a hot emerging field in computer science. And some buzzwords you'll hear in this are confounding correlations, forks, mediators, colliders, intervention, counterfactuals. I like to give these because with some of these buzzwords, you can then Google and kind of learn more about them. I think the book came out in February 2018 or something. I think early 2018. But his understanding here is the math. We've never had the math to ask the question why. So one example he gives in the introduction is you have a barometer that measures pressure. So you have some certain amount of pressure. You're measuring it. So you have B. You have what the measurement device measures equals some type of constant, just proportion to pressure. So B equals, let's say, some constant K to pressure. B equals Kp. In simple algebra, most people will then kind of tweak this and say, okay, well, we can say pressure, we can just move the equation. We can say pressure equals B over K. But there's nothing in this algebra that tells you anything about causality. With these equations, you could easily think that if you went to the barometer and you moved it, you move the measurement, that you're going to affect the pressure. We know that's not the case, but there's no math, there's no way to communicate causality in our language and in our mathematics. And so he's basically, there's a new calculus out that he's talking about that does this. And with this, you can now calculate correlation values for causality.
You're talking about do calculus?
With the do operators, yes. So with that, we want to thank you for spending your lunch here. This is how you can join us. So we have a hands-on project specifically for registry data. We created our own pseudo registry because we don't have access to the true registry data from the state. We created our own registry data, pseudo, so that we're actually studying these data privacy techniques and just getting hands-on with them and saying, well, what if we add differential privacy or federated machine learning? What does that do to the accuracy and privacy of the information that we're sharing? So please join us, and then if you're interested in John Lingel's causality study group, there's a channel on our Slack channel too. I think they're meeting monthly, and there's a channel on our Slack channel for that as well. So you can do this link to join our meetup, and then once you're on, you'll get an invite to Slack, which is how we communicate, and these are the two channels for the two projects. So with that, I'll open it up for discussion, questions.
I have seen in the newspapers about cancer clusters in the south of Charlotte, like I've heard about Sedgefield, they call it brown areas that used to be maybe some industrial site, and then it hasn't been cleaned enough, so they say if you buy a house there, then you just don't plant veggies. That sounds to me a little, like where would I find out information about that? What about the water? I mean, okay, I know if I don't plant any eggplants, I'm not gonna get a cancer. What about the water? Or is there any way to find out then, once you think of buying a house?
So right now, I think your best bet is to ask your county health department or even the North Carolina health department for more information about that. But that bleeds into a good question, because there are some people are concerned that for some of the cancers like thyroid, that maybe it's related to specific areas like you mentioned. For example, could it be related to power plants? Could it be related to coal ash? And maybe maybe the other brownfields I think you were discussing for other cancers. And I actually tried to ask the state for this. I said, well, can you take every power plant in North Carolina that there's coal ash in, or that is coal fired, and give me an enrichment for those areas? Don't hear anything. Nothing. But if we had the data, we could start looking at that. So I think those are the right questions, and the data can help you figure that out. But I don't think we're there yet, and I think we have to advocate for kind of better access, not only better data, but also better access to the data we already have.
What are the other sources of data that you can look at? So you look at the state data, but is there other national registries that are available that would have some of that geodata, CDC, those kinds of things? Are those areas that you are looking at to explore?
We are, yeah. The more data sets we can use to add in the more information we'll get. So it's interesting. I forgot to spend time on where does the North Carolina Cancer Registry collect its information. So I think for the last few decades, anyone that's got cancer in North Carolina was required, the hospital was required to send that incident, that diagnosis of cancer to the healthcare registry. And a lot of the data that North Carolina has, you can also view through the CDC's visualization portal. In fact, I like to use the CDC's website for North Carolina data better than the North Carolina's website. I think it's roughly the same data. Not 100% sure. It looks like the same data to me, but the CDC is just has better maps, and it's easier to navigate. SEER is another site. And
Bill, did you get down to the census plot on that information, or no? Can you get to the census level data, the census plot on that?
I found a website from Mecklenburg County that actually has tracks, that has GIS tracks for like a lot of really cool things like waste, different waste. You can pull right into your GIS software, and I'm pretty positive it was by census tract. So I think there are initiatives within Charlotte, even to Mecklenburg County, to make some of that data more transparent. But yeah, the more we can pool, even from EPA's website of kind of required release disclosures and things like that, the more we can pool in, the more questions we can ask.
That's it.
Thank y'all.
Thank you for the time.